Okay, today, the big reveal. Okay, so far we really haven't seen what cubic functions actually look like. And here we go. I should have sort of flashed them up on the screen to give you a sort of nice surprise there. But these are some examples of cubic functions. We've only seen what I consider, and I don't mean it any sort of offense, but we've only seen these inflected cubics so far, which are a bit bland and unexciting, but cubics can take many shapes and forms, and these three are just examples of different types of cubics. Now, they're really reliable because they'll always produce a solution. So you're always going to get a solve on that. And again, that's unlike a parabola, which we can't solve in some scenarios, okay? Now, we can get one solution, we could get two solutions, but the maximum we can get is three solutions, okay? So this one would have one solution. This one we can see has two solutions here, and this one we've got three solutions, okay? So what we've been doing with cubics so far is taking them from expanded form and putting them into factored form. And the reason we've been doing that is so that we can set it up for the null factor law. So what we're going to do is go through and solve a couple of cubics. All right, so let's have a look at this one here. So the null factor law says that either A times B times C means that one of these have to equal 0, could equal 0, in which case x could equal -3, x could equal 4, and x could equal 7. And we're done. They are the three x-intercepts. And so if I was sketching this, I'd put one at -3, another at 4, and another at 7. And we'll later learn that this is a positive cubic, and it's going to take this form here. Okay, you don't need to worry about that yet. Right, this one here, we're going to note something interesting about this one, okay, this particular solve on this. Let's go ahead and solve it. So I've got x plus 1 could be equal to 0, in which case x is going to be -1. And I've got 2x take 1 squared could equal 0, in which case x is equal to half. Now, let's just asterisk this solution here because something special happens when we get this squared factor. And what's going to happen is we've got -1 and we've got a half. And I know for a fact that this is a positive cubic. What's going to happen is we'll get a turning point on the x-axis for this particular x-intercept here, okay? You don't need to really worry about that yet, but just acknowledge that this is a special one because of the fact that it is squared. All right, so this one here, we're going to solve this one. And remember to use the null factor law, what we're going to have is either the right or the left's got to equal 0. So I'm just going to change this to be x cubed take 4x equals 0. And we're going to grab x as a common factor out. X squared take 4 equals 0. Apply the null factor law, x is equal to 0. X squared take 4 could be 0, in which case we've got x equals 4. X equals, when we root both sides, x is equal to plus or minus 2. So that means that this particular cubic would have x-intercepts there, one at 0 and one at 2. And we'll find later on that it looks like that. Again, I'm not too worried whether you know that or not. All right, this one here, we're going to solve this one. So it's 1/3, 5 take x cubed equals -9. So what I'm going to do is use the inverse operations method on this one. So notice that the way I solve each one here depends, and it depends on, well, what it looks like. All right, so 5 take x cubed equals -27. All right, what I'm going to do is third root both sides to get rid of this power 3. Now remember, we can third root a negative number. So that's 5 take x equals, and the third root of -27 is in fact -3. So when -3 is power 3, it equals -27. All right, this is going to be -x equals -8. X is equal to 8. All right, and on to this last problem here for this video, okay? So what we're going to do is solve that. So all of these ones were in particular forms, all right? And what we want to get it into is a form that we can solve. Now, with these particular forms here, what I'll generally be able to do is put them into factorized form and use the null factor law. So that's my first attempt. So I'm going to say let p of x equal x cubed, take 4x squared, take 11x plus 30. And I'm going to search for a linear factor. So I'm going to try p of 1 first of all. It's going to be 1, take 4, take 11 plus 30, which clearly is not 0. P of 1 is not equal to 0. Now, I hope this doesn't get embarrassing, i.e. that I have to keep searching for a long time. Negative 1, I think it might be negative 1. P of negative 1 equals negative 1, take 4, plus 11 plus, no way, is not equal to 0. Okay, let's keep trying. P of 2, 8, take away 16, take away 22 plus 30. I think we have a winner. That's negative 16 take 22 is negative 32, negative 38 plus 38 equals 0. Therefore, x take 2 is a factor. All right, so now what we'll do is we'll attempt to factorize this cubic, okay? Now I'm going to do it two ways. The first method I'm going to do is long division, okay? So if you want to do long division, copy that down in your notes. The second method I'm going to do is equate coefficients. So skip forward, I don't know, like long division takes ages, so, you know, skip forward an hour. That's a joke, no, but skip forward maybe a couple of minutes until I equate coefficients. So here goes the long division. X take 2 into x cubed take 4x squared take 11x plus 30. All right, let's pound out the long division. X squared, x cubed, take away 2x squared. All right, so there we go. So we've got P of x equals x take 2, x squared take 2x take 15. All right, and then what we're going to attempt to do is a factorize on the quadratic. So that's going to be 5, 3, x, and one of them is negative, and it's that one. P of x equals x take 2, x take 5, x plus 3. Okay, and so we're saying 0 equals the factored form of the original cubic. X is equal to 2, x is equal to 5, and x is equal to negative 3 when solved. All right, so that's the long division approach. Now what I'm going to do is use the equating coefficients method. So remove them. Okay, so we know that P of x equals, and the factor we found earlier was x take 2, and what we've got to do is think about the quadratic that would sit in this spot. Now that must be x squared, and that must be 15 plus b of x. No, that's take 15. All right, so what I think about is how I make my x terms, which is negative 2bx and negative 15x, and that will equal the x term over here, which is negative 11. So that's going to be when factorized x, negative 2b take 15 equals negative 11x. Okay, so negative 2b take 15 equals negative 11. Negative 2b equals 4, b equals negative 2. So therefore P of x equals x take 2, x squared take 2x take 15, and cross method on that, 5, 3, neg x, x take 2, x take 5, x plus 3, let it equal 0, x equals 2, x equals 5, x equals -3, which should have been the same result that we got if we did long division. So experiment around with different techniques, okay, and go ahead and do exercise 16.